Hi everyone, and thanks for tuning in. My name is Zach Jaffe, and I'm the GIS coordinator at LandTech Consultants. Today, I'm going to be talking about 3D GIS for asset management, specifically focusing on water and wastewater utilities. I'm going to be discussing the background information and how these projects and solutions came to life, the challenges we were faced with by our clients, our solutions for indoor 3D GIS, which is going to focus on the assets inside water and wastewater treatment plants. For example, those valves, pipes, fittings, pumps, etc. Then I'm going to discuss our solution for outdoor or subsurface 3D GIS. A little background on myself. As I said, I'm the GIS coordinator at LandTech. I began my career in water utility operations, where I then transitioned into GIS and surveying. I now focus on 3D data acquisition and GIS implementation. That being said, I've utilized these tools in the field as a field tech and as a GIS tech and manager. And as you can see, I've bounced around between New York, Texas, and now reside in Massachusetts. LandTech Consultants is a multidisciplinary civil engineering and land surveying firm based in Massachusetts with an office branch in southern Florida. We began as a smaller firm primarily focused on private land development, but through the years we have become early adopters of advanced technologies including GPS, total stations, LiDAR laser scanning, building information modeling, or BIM, in GIS. A lot of our work consists of performing existing condition surveys and documentation for water and wastewater treatment plants. The deliverables for these projects were in the form of point clouds or BIM models. Our clients were coming back to us and saying, these models are great, but how can we integrate them with GIS for the purpose of asset management? And how can these models be used in the field to improve maintenance and operations? I'm going to walk you through what our workflow and solution look like to solve these two challenges. You begin with a 3D point cloud that's collected via a LiDAR survey. Each one of these points in the point cloud has an XYZ value with millimeter accuracy. We then take that point cloud and build a BIM model from it. This is an example of the BIM model using Revit. Utilizing the Esri Autodesk partnership, we import the BIM model into ArcGIS Pro and convert it into 3D multi-patch features. It is at this point that we georeference the model, placing it in its real-world location, as well as adding attribute data, or attribute tables. The model is then digested by VGIS to be viewed in augmented reality, or AR, to be viewed by field techs before going to the job site or while on the job site. So, there you have it. Our answer to how to integrate the BIM models with GIS and how to deploy them to the field to be utilized by field technicians. So I'm going to play a few videos showing you what this workflow looks like live. This was a pretty cool project we did in Miami where we used a variety of different data acquisition techniques, including a drone flight, a terrestrial LiDAR scan, and conventional surveying. So as we look at the point cloud, we go from outside and move inside. Notice the high level of detail. You can see all the way down to the bolts and nuts of these valves and fittings. Here we transition to the GIS model in ArcGIS Pro. Again, notice that same high level of detail where we can see the bolts and nuts. Because these are GIS features, you have the same functionality you're used to with traditional 2D GIS. You can click on an asset and view the associated attributes. Here's an example of a work order associated with that valve. You can also integrate these models with asset management softwares like IBM Maximo, for example. Here's an example of a hyperlink to an online catalog that might have some information pertaining to that asset. And again, because these are GIS features, they can be deployed enterprise-wide, whether that's out in the field on a mobile device or in your office on your desktop. And this is just an overall scene of the treatment facility. So that was a video demonstrating the model and integration in GIS functionality. This video is going to demonstrate what a workflow might look like to perform a valve replacement inside of a water treatment plant. So here we zoom into the model that was created from an original point cloud. A standard query for valves that need to be replaced is performed. As we zoom to the feature, we notice the valves are symbolized by the unique attribute, where all the valves that need to be replaced are color-coded red. You can click on the feature and view the associated attributes. Here's an example of the asset in an asset management database with the work order attached to it. Here's another example to a hyperlink that might contain specific information regarding that feature, like specs on maybe how to replace it or instructions. And here we transition to the field, where the field tech is viewing the model on their mobile device in VGIS in augmented reality. The model they are seeing is overlaid on top of the actual assets. And because this error model is pulling directly from their geo database, all its symbology and attribution will be the same. The field tech can click on the valve and view the associated information. They can access their asset management database or any of the other hyperlinks. Again, the field tech's clicking on the catalog to view the specs or maybe instructions on how to replace it. So these models and workflows, they're cool, they're slick, they're cutting edge, they definitely have that wow factor, but what's the point? What value or benefits are you going to see by implementing this kind of workflow? I'm going to use a valve maintenance program as an example. Before going to the job site, the field tech needs to have the answer to two very important questions to perform their tasks. First, where is it? And second, what is it? Where is the valve located? And what is the valve? What kind of valve is it? What tools or pieces of equipment are they going to need to fix or replace it? Typically, you might have the asset information in an asset management software, which essentially is a line item on an Excel sheet. If you're lucky, you have some sort of plan or schematic of the facility. But when your field tech gets to the job site, nothing makes sense and they have a nuclear meltdown. For example, valve 21 isn't where it's supposed to be, it's a different kind of valve, or they don't have the right tools or replacement parts to fix it. Ultimately, they have to go back to the shop, make a return trip, wasting time. With 3D GIS, they're able to query for that valve by its unique identifier. ArcGIS will take them directly to the location of the valve where they can visualize it as if they are in the room. They can click on it to view the associated attributes to better prepare them for the field. Then, while on site, they can view the model in AR to locate and confirm that they are at the correct valve, and again can view the associated information. And to briefly touch on the modeling aspect of the workflow before moving on, as I pointed out, you've noticed these models were extremely detailed down to the nuts and bolts of the assets. There are many different levels of detail or development that works for these workflows. As you can see, LOD300 has more generic looking block features for the pipes and valves, while LOD500 you can see down to the bolts and nuts and even the light switch on the wall. This is an example of a chemical facility we modeled in BIM and integrated with GIS. As you can see, it is a very intricate and complicated piping system. The valves are not as detailed as the previous model shown, but it serves the same purpose. Transitioning to our subsurface utility solution. Again, our clients came back to us and said, these models are great, but how can we use this technology in the streets when it's 2 in the morning, there's a main break, and we need to locate a valve to shut the water off when it's buried in 6 inches of snow? Being in New England, this is a fairly common problem, but even in places that doesn't snow, finding assets can often be difficult. Instead of using a standard existing condition plan that's ripped and covered in coffee stains for the past 30 years, through various data acquisition techniques, a 3D model of the underground pipe infrastructure is created. The model is imported into ArcGIS Pro, where the above ground features are added as well, like the buildings, trees, and streetlights, creating a digital twin, taking real-world conditions and bringing them into the digital environment. Again, utilizing VGIS, the model is viewed in AR while on site. Here's another video showing what the workflow might look like live to locate a leaking valve in the street. We are zooming into the digital twin where we can see the above ground features, as well as the below ground features. Making the ground transparent so we can now see those underground features. A standard query is performed to view the leaking valves. Again, it has that same functionality that you're used to with any other GIS data. Zooming to the valve location, you can say, okay, it's a hydrant valve, it's across the street from Dunkin' Donuts just in case I need my coffee. You can click on the valve to view the associated attributes. Again, you might have hyperlinks attached to it, a picture, a work order, any other information that you might find useful. Then, while on site using VGIS, you can quickly identify the location of the leaking valve. The dashed lines represent where you need to be on the ground to be directly above the underground feature. The field tech can click on the asset to view the associated asset information because, again, all of this data is being directly pulled from their geodatabase. They can also make edits to the attributes while in the field that are sent back to the geodatabase in the office, all in real time. This will definitely help workflows when locating assets, whether or not it's buried in 6 inches of snow. There are a lot of benefits to implementing this kind of workflow. For the indoor solutions, you are now adding a visual and a location to your indoor asset. Before this kind of workflow, this was not possible or very difficult to achieve. The second, these are GIS features, meaning you are easily able to edit the attribute data and use that same GIS functionality you're used to. You're also able to integrate with third-party software like VGIS or an asset management platform like IBM Maximo or CityWork, for example. Time and effort is saved in the office searching for asset information because you're using your geodatabase as your centralized storage depository. You have the physical asset location information as well as the attribute information all right there. It saves time and effort for field technicians because they're able to view the models and attributes before going to the job site or while on the job site to better prepare them to locate assets quicker and eliminating return trips. Again, because these models are GIS features, they can be distributed enterprise-wide. From decision makers in the boardroom to field crews digging a ditch, everyone has access to the same data all in real time, ultimately allowing for better and more informed decisions and actions. Now, there are 2 important things I want to note here. The first is, previous to this kind of workflow, these models were really only used by engineers or planners. But now, everyone from those engineers to field techs can learn to use and benefit from these tools. The second is, you don't have to start from the beginning, meaning if you already have a point cloud or a BIM model for your organization, you can start the GIS integration process from there. So, what's next in this workflow? Things we are currently working on for our clients are integrating with real-time sensors like SCADA or loggers. The other is figuring out a way to perform network analysis on the 3D modeling infrastructure. Esri has been doing a great job in releasing and producing tools for 3D GIS, and I'm really excited to see what they're coming out with next. That was a quick overview of our workflow and solutions for the challenges our clients faced us with. If you have any questions or would like more information, please feel free to reach out and I would be happy to answer them for you. Thank you all for listening, and I hope you enjoy the rest of your virtual conference.